This is going to be a movie about using Carlson PtCloud in AutoCAD. The file will be the eBee SenseFly processed PtCloud and image, and I will create a new drawing. Do exit. And we'll load PtCloud. If I come up here, go to PtCloud Setup, you can see it's set to Point Tools, which is correct, the default. Go to PtCloud's, the second menu item, PtCloud Manager. Select, we're going to create a new file, and we're going to take this and go to the G drive. And I'll create a new PtCloud project and work the example from scratch. Okay, when I do that, I have two windows. You can see that I have the PtCloud window and I have the AutoCAD window. So we're going to go to here, and the first thing I want to do is go to the Clouds button here. I highlight it, hit the right key, come over here and do import, and I can import from several types of formats. And the format that's created by the eBee drone SenseFly software is a LiDAR or LAS file. I pick LiDAR, go here, and I'm going to make it current. You can see there it is. There's the file. It's a 2 gigabyte file. I'm going to pick open. And this does take a little while. And let's see, it's exactly 3:22. Let's see how long it takes. I'll even let the movie run. It will be, even if it's a minute or two in the movie, people can fast forward through this. I just wanted to see how long it takes. Okay, and now we have a cloud. We've imported it, and the first thing I want to do is save. As soon as you save it, it goes so you know you've saved it. So we've saved this file. Let's go down to Properties, and you can see that there's 63 megabytes of points in the cloud. That's quite a few. There's points, they have XYZ, there's no intensity. That is brightness attached to the points, but there is color, RGB. So I pick there. Now, the next thing I do is resample, and that is decimate. And I want to decimate this file down to about 100 kilobytes. And to do that, if I type in 650 divided by 60, almost 65 million, I should get a little less than 100 kilobytes of points, and we'll find out very quickly. Shouldn't take too long, and you pretty much have to look down here and wait till it's done. As soon as it tells you it's stored the file down there in the command history, you know that it's completed. Okay, and there it is. 97,000 number of vertices. Let's come down here, pick this guy here, 97,000. Okay. Now, next thing you want to do is select this, come over here, and I don't want to make a cloud of the cloud. I want to make a mesh. Now, don't ask me why they called it a mesh. It's a TIN file inside of Carlson PtCloud, but it is not a Carlson TIN file that's in the mining civil package. So, but I have to create a Carlson PtCloud TIN file before I can export it to a Carlson TIN file. So I pick the right key on that menu, create, and then pick mesh. And I'm going to come up here and I'm going to type in mesh underscore 100 kilobyte, and use filters. I'll turn that off. Mesh limit, it's less than 100,000, so I'll take the smallest size. Pick the green button, and now it's going to create a mesh, and there is the mesh file that it created. Again, I'm going to save and come down here, and we're going to go to export, and here I'm going to create this is going to be cloud underscore 100 kilobyte, and I think that's the only file there. I'm going to pick save, and it's exported that file. I've already saved everything. Now I'm going to close out of PtCloud. We're going to switch to the civil menu, and I'm just going to contour from a TIN file. So I'm going to pick this guy, and I'm going to contour 1x, 5x, label 5x. Okay. And where's the, there it is, cloud, 100 kilobyte. And it appears it's done. And there is the contour map. Now, I can obviously see some distortion up at the very top right there. So what I want to do is type in 2DP, elevation. I'm going to type in 700. And we're just going to pick a point here. And close. Okay, I've created a polyline, and what I'm going to do now is save this. Go to the G drive, BNI, and we'll just call this BNI-work. And what I want to do is export out a PLN file. Hit return for Carlson. I'll overwrite this one. use Z coordinate, you bet, and pick that. And there we go. Now, I want to go back, and what I want to do is I want to create a file for just this area for the mind area. So I'm going to go back to PtCloud. And we're going to go open. I think I called it Word 2. I'll find out real quick. Yes, I did. Okay. And at this point, I'm just going to hit the right key here, do import. There is the perimeter file. And now, I want to make a scene of the entire tin. So we come down here. That is a view. We're a scene. Pick view. And this is good, 3D. Come down here and pick color. There's only one option, direct. That's RGB direct. Pick OK. And I'm going to come up here, position that. Okay. And there you go. Now, see the red dot right there? That is, now here's the XY. As soon as I move off, it's Z on the outside. So I can rotate this. If I move in here, I can actually go up. Now notice the Z is down, so I went the wrong way. I want to go that way. See how the Z goes up? Okay, then you want to rotate it. If I move in, it's an XY cursor and a Z. And now I move it right about there and window up. Now, if I want to actually rotate around this point, I can go up to camera tab, change from automatic to custom. Pick this little green eyeball. And as I move over here, it says specify camera pivot position, control click. So I hit the control key down and then I just pick right there. And now if I want to rotate, see if I go over here, I do Z. And I can rotate and look at this right there. Pretty cool. Now, if you ever get lost, what I do is I go up to view front and then I do plan view and then I do zoom extents. And that brings it back. Now you can see my pivot points changed to where I wanted it. And now I'm going to go back to project. And now I want to bring in this polyline on top of this cloud. So I hit the right key here. And I'm going to view. And I want to append to an existing, not create a new view of just the polyline. That would be pretty boring. And I want to make sure it's 3D. Pick OK. And there it is. I've created a polyline. Now at 700 feet, it plotted on top of my contours. So I can see it. If it was at 0 elevation, I wouldn't see it. It'd be underneath, unless I change the aspect view. Okay, at this point, I want to go to action and create a new inclusion. I want to use that polyline as an inclusion polyline and create a new cloud. So I pick this guy and I move over here and it says select inclusion polyline, control click. So I come over here and I just pick right there. There. I had to pick it twice. Now that's in red. It's created that. I pick end mode. And now you come down here and you pick create cloud. I pick create cloud. And it's going to create a cloud name. And I'll just say mine pit. So just the area of interest. Pick OK. And you have to sit back and let it create a mine pit. So you could, by using that inclusion selection set, you could actually create little clouds of your cloud and work in smaller areas. So if you want to use more of the points, because I'm going to do another 100K file of this point cloud, and essentially go from there. Okay, so it's taken a little while. I've probably have, that's 63 million points in all. That's probably maybe half the file. So I have to wait a little while. So it looks like it's done. It has been created down here in the command history. So I'm going to pick end. If I do none, I can actually get rid of that red hatch there. Let's go back to project, and there's the new cloud pit. If I come down here and do properties, it says it's got 11 million. So obviously if I say 100, I'll get close to 100,000. Now one thing I've learned about PtCloud is save it. I'm actually going to exit out and come back in again. You're going to say, why am I doing that? Well, AutoCAD has a lot of problems with big files, and PtCloud oops, I didn't want to do new. I wanted to do open. Okay. Nope, that's the wrong one. Close, open. There's the file. Okay. Now, I'm going to do resample, and I'm just going to type in 100. I think that's, and we're going to just say resampled 100 kilobyte. Close approximation. And again, you just look at the command history over here and wait till it says that the new cloud has been created. So far I haven't actually stopped the movie and then paused it and then started again. So it created total vertices 11 million, and it's down to about 112,000. All right, so I'm going to save that. And at this point, I'm ready to go down to properties. We know that it's 112,000. And now we're going to do create mesh. And this one's going to be mine pit 100 kilobyte. And 250,000 is plenty good. Mesh created. Oh, well, I guess it's already created. Okay, and at this point we just come down here and do export. And here I'm going to type in cloud mine pit 100 kilobyte. Okay, we'll save that. And at this point, if I want to go to the section package, and I'm going to type in PL for polyline. I'm going to do trim. Okay, we're going to go to the civil package. We're going to go to sections here and input section alignment. And I'll just call this cloud mine pit. I want to create it. Yeah, I want to create it. Then it says select center line. I'll pick that guy there. Starting station is 0. Use perimeter polyline, you bet. And select perimeter polyline. And 0 to 20, 20 to 40. Okay, let's go ahead and save it. Exit. So that's where we're going to pull cross sections through this site right here. Type R for redraw. And we're going to come down here and do create from grid section file. And here it is. There's the tin file that we exported out. And we'll just pick OK. And it wants to know, choose alignment. and wants to know what file you're going to output. I'll just say cloud mine pit, and at this point we're going to go up to input edit section alignment. First one looks a little crazy. We'll just drive through at 25 miles an hour. Alright, maybe we'll just hit F3 and go through them. There's 500. And you can see the pit as we're driving through them. Alright, and there's 680 20-foot cross sections. Didn't change anything. And that pretty much ends the example. Now I just want to see what the difference is between these cross sections and pulling a 10 through the other cross sections. So I'm going to go up here and do create sections right here, and this is my other 10 that I created. Now that's for the whole site at 100 kilobytes, and this one's going to be whole mine area. Okay. And out of curiosity, let's take a look at both of them. All right, I'm going to pick that one as my main one. And for my second reference file, I'll pick the whole mine site. We'll go to 20. Okay, I notice there's just quite a bit of discrepancy in the first one right there. But then every one after that looks just great. So there must have been some real craziness in the field data right there. But I'm just going to go through and pretty much just looking at the site, you can see there's not much. I mean, these are both decimated files, but you can see that the sites aren't too bad in difference. So the decimated example isn't too bad. Okay, that's pretty much what I wanted to show you. And I do want to forewarn you, I didn't change anything there. I do want to show you that if I go up here and do draw triangular mesh, and I draw my cloud pit area, use inclusion area, I'll say yes. And no exclusion area. I just want to show you that's what 100,000 points looks like close up from that point cloud. And I do want to forewarn everybody that if you, and I actually created a 5 million point file and not a 100K file, and made a 10 file within the pit just as an experiment, and AutoCAD choked. I mean, it didn't crash AutoCAD, but it choked that it would take 20 minutes to save the drawing, 20 minutes to turn off or on the layer that I drew that mesh on. So I highly recommend that no one try to make a 10 file greater than 1 meg and plot it inside of AutoCAD as 3D faces or 3D lines, just because of the amount of memory and time it takes. I have 8 GB of RAM on this computer, and it took 20 minutes to freeze this layer. As you can see, these are only 100K right here, and it's almost instantaneous to work with those. And you saw the cross sections, and if I did a volume between the two, and I'm just going to come up here and do volumes by triangulation to surface triangulation here. We're going to grab the cloud 1 megabyte, I'm sorry, the 100 kilobyte file. That was the file that I just made. And then this is the cloud mine. That's the one that I made that's smaller. Select inclusion area, no exclusion perimeter, and I'm just going to go ahead and pick OK. What I'm looking for is the difference between cut and fill. Obviously, we're going to know that there's slight differences. In that first cross section, I noticed some significant differences, but the depth, average cut depth difference was 0.1 over the entire site, 0.12. Notice that we had 557 cubic yards, 620. So the cumulative import was over the entire site was 63 cubic yards. So you're going to see plus or minus, 50 cubic yards differences on your earthwork if you decimate your files, and maybe 100 at the worst. That's 10 truckloads. But the fact is, that's how, if you want to speed things up and work very quickly with the point cloud, you want to decimate the data so that you're working with 100 to 250,000 point clouds in the areas of interest you're working in. And I also showed you, using the 2D polyline, how you can define a new area to create a new cloud of just the area that you're working in this case, the pit, as opposed to the entire map. Okay, I think that's pretty... Oh, I haven't brought the image in. Okay. Actually, I want to bring in the points. So let's go up to settings, drilling locate points. Let's set it to 200. I want to set the size to 0.125 and the text size to 125. And we'll just go up to points here and do import text ASCII file. And I'll find out real quick if the northern easting is correct. And we'll just call this eBee. Okay. Oh, you know why? I inputted that ASCII file. Gee whiz, user error. What did I do? Skip header line. Okay, 0. I was going to say that's why it didn't come in. Okay, I'm going to do locate points and we'll do draw all. Okay, that tells me that that tells me that the points came in wrong, so it must be XY. There it is, XY. Override all. Locate points. There we go. All right. And LA for layer. Where is point elevation is blue. We're going to make that yellow. All right. Well, we got 640, so 639.56, and down here we got 606. And if we go up to Drawing Inspector, Display Elevation, 607, 608, 606, okay. All right. Okay, I just discovered that this is that image file. I don't have AutoCAD map on here, so I can't bring in the image file because it's georeferenced, and AutoCAD requires that you own AutoCAD map on here. So I'm going to save this, BNI work, and we're going to exit out. And I am going to, unfortunately, load up IntelliCAD. Not unfortunate that I'm using IntelliCAD, but I don't have AutoCAD map on my computer. IntelliCAD, we automatically just use the georeference file. So I'm just trying to end this movie by showing you that you can bring the image in as long as you have AutoCAD map georeferenced. So at this point, I'm going to do open, go to BNI. There it is. And it has to convert it to a 2010 drawing, which it will. File will successfully convert it. And there it is. And I'm just going to go over to units. We have to go to 8 places. All right, well, let's just plot the image. Okay, I think it's going to do it this time. All right. Come down here, display order, send to back. And there we have it. If I do zoom, and there is the image and the point cloud contoured using the eBee imagery and drone point cloud data.